This is Dr. Indradeep Kumar, okay, Assistant Professor IARE, Hyderabad. So in this video, we will see the question bank discussion module 1 part 3. This is the third video for question bank discussion of module 1. Okay, so now the question is: a polished steel bar is subjected to axial tensile force that varies from 0 to P max. So instead of that value earlier they given us minus 50 to 150. So here instead of giving that one, they given 0 to P max. Okay, it has a groove of 2 mm deep and having a radius of 3 mm. That 2 mm groove deep is there and 3 mm radius is given. The theoretical stress concentration factor and notch sensitivity factor at the groove are 1.8 and 0.9. So theoretical stress concentration factor is 1.8 and notch sensitivity is 0.95. Already we had seen in the cantilever beam their notch sensitivity was 0.9. The same way we can. The outer diameter of the bar is 30 mm. This time diameter is given. Earlier we found the diameter, now this time diameter is given. The ultimate tensile strength of the bar is 1250, that is 1250 megapascal. The endurance is in reverse bending is 600 megapascal. So in reverse bending that is given 600 megapascal. Find the maximum force that the bar can carry for 10 to the power 5 cycles. So this time cycles is given up to how many cycles that will be there and with 90% reliability. So again R value is given, that reliability value as 90%. Okay, so now what we have to find this time the maximum force. Earlier what we found with the force we are given, right? So this time we have to find this P max and diameter is given. Earlier same P max was given, P max, P mean was given and we found the diameter. So in similar way we can find for this also. So let's see. P is 0 to P max, that is varying. S ultimate given as, sorry, here it's megapascal. S ultimate as 1250 megapascal, S dash E given as 600 megapascal, KT as 1.8, Q as 0.95, R as 90%, and N is given as 10 to the power 5 cycles. Okay, so now SE dash is what is given 600 megapascal, that we can write as 600 Newton per mm square, and that is what. So see the question: a polished steel bar, polished plus Ka for polished surface, Ka is equals to 1. Ka is what? Surface finish factor for 30 mm diameter. K from the chart, Kb is 0.85. Kb is the size factor for 90% reliability. Kc is 0.897 and Kc is the what? Reliability factor. This Kb is the size factor and K is the surface finish factor. So surface finish factor is the polished. The surface finish factor will be 1. Right? For 30 mm diameter, the size factor is how much? 0.85. And reliability factor, that case is 0.897 or for 90%. That you have to check properly how much the reliability is given, and from that for that reliability what value of the Kc will be there. Okay, so these things are given, right? These things we found from the table depending upon the given condition. Earlier the metal name was given like SCC, that is steel name. Here that is given as polished bar, right? So according to that and whatever the reliability are there, with that you can find from the table, right? So these are the values what is required. Okay, now just apply again the notch formula. So Kf equals to 1 plus Q into Kt minus 1. Kt is given, Q is given. So after putting the value, Kf equals to 1 plus Q is 0.95, Kt is 1.8 minus 1. Right. So after simplifying, what you will get? That as 1.76. Where Kf is what? Fatigue stress concentration. What we are finding, that is fatigue stress concentration factor. In previous question also we found, right? Kf and then Kd. Kd is what? 1 by Kf. Again we use this formula earlier also. Okay. So now Kf, that is 1 by 1.76. This value that will give you 0.568. Okay, so now SE is what? SE is Ka, Kb, Kc, Kd into SE dash. Now we have Ka also surface factor, that is 1, Kb, Kc, Kd. Just put the value. So Kd is what? Modifying factor or stress concentration factor. Right, that is 0.85. Just here we are saying, just here. Kd is given there. for this that value. Okay, so now after substituting all the value, right, just multiplying, this one is given as SE as 600. After multiplying this, what we will get? SE value as 259.84 Newton per mm square. Okay, how much reliability is given? That 90%. So 0.9 SUT will be what? Right? So this is 0.9 into 259.84. That will give you 11.29. Now take log both sides. So log of 0.9 SUT, sorry, here it's not there, that is equals to log 1125. From here, what you will get? 3.0512 value. Okay, so now just see from this diagram. So just see a 3 point. So now this is what? The Goodman, and for fatigue cycle strength of 10 to the power 5 in this one, right? 10 to the power 5 cycle. That's why I just see a log 10 to the power n is given. So that in terms of 10 to the power 5 cycle, we have to put the value of n, log base 10 and 10 to the power 5. So that will give you the value of 5. Okay, so now just see this diagram. From here, all the value we found from 3, 5, 6, whatever is there for F and B. So from, let's see here, AE, right? So this will be this where we are, right? That is AD, okay? AD into EF, okay? Divided by DB, right? This one. So just put the value whatever is there. So AD will be what? So just we found that the total right here. Okay. So now AD is that this is the value of AD 3.0512 minus 2.4147. That is the AD into that EF value. So just see here. EF, right? So this, right, minus that 3 value. So 5 minus 3 divided by DB. DB, that is 6 minus 3. Okay, because this is 3. Before that also is there. Up to from 3 we are starting. 3, 4, 5, 6 is there. So don't get confused. This is up to 5. So this distance is how much? 3, 4, 5. So 1 here, 2 only. So 5 minus 3. Okay. This is DB is up to 6. So 6 minus 3. Okay. So this is 6 minus 3. So after putting what we got? A equals to 0.4243. Okay. Now for that value just. So log SF, log 10 SF, right? That is equals to 3.0512 minus AE. AE just we got, right? Substitute that value. So after substituting that value, what we will get? Log SF as 2.6296. Now take anti-log of that one. Anti-log of, because log SF is there. So log 10 SF equals to 2.6296. Right. So now we have to find SF. So SF will be equals to anti-log, that is e to the power 2.6296. Right. So after this, what we will get? SF equals to 423.55 Newton per mm square. Now we have SF. Okay. Now P max, let's just assume P max as P and P mean as 0. So we have to find this P max, that value of P. So P max, P mean 0. That is given, it's running from 0 to P max. Now same way P mean will what? Half of P max plus P mean, right? That is after putting P plus 0 by 2. So 1 by 2 P. P mean will be P available or P, sorry, alternating, or PV will be equals to what? Half of P max minus P mean. So again that same will be 0 because we are subtracting 0. So PM and PA in this case, how much? That is same. So now theta will be sigma A by sigma M. Sigma A by sigma M is what? Sigma A by A, that capital A by PM by A. A get cancelled, that PM by, sorry, PA by PM. What is the PA? PA is 1 by 2P. PM is also 1 by 2P. So these two will get cancelled, 1. So tan theta equals to 1. Hence theta equals to tan inverse 1, and that is theta equals to 45 degrees. So now just see, this will pass through the 45 degree exactly, that's from origin and at 45 degree. Okay. Now equation of line, that straight line equation that we are using, that intercept form. So SA by whatever the intercept is, therefore 423.55. So just see, this is the sigma A, and here is the 423.55, and in this case 1250. So that's this x intercept, this is y intercept. Right? So SA by, so y by y intercept plus x by x intercept equals to 1. That is straight line equation. So SA by 423.55 plus SM by 1250 is equals to 1. That is equation of line of which one? That OX. Equation of this line. Okay. So now, and another one is what? SA by SM. That already we found that tan theta as 1. Right. So from here, SA equals to SM. In previous question, what we got? SA by SM equals to 2. Here, SA by SM equals to 1. So SA will be equals to SM. No replace here. Okay. So after replacing anything, you can replace either SA or SM. So I'm replacing SA. SA by 423.55 plus SA. I'm replacing this SM to SA by 1250 equals to 1. Right. So after taking this one, what you can say, just take LCM and simplify. Then you will get SA equals to 316.36 Newton per mm square, and that is equals to also SM. Or simply you can say SA equals to SM equals to 316.36 Newton per mm square. What is SA? That already you know, that alternating stress, SM as mean stress. Now we have what? SA, alternating and mean. Now maximum force on the bar. Right. So SA as PA by area, alternating. Right. So PA. So PA is how much we got? 1 by 2P, or half P, or P by 2 by area. Right. Now area is left. So SA will equals to P by 2 by area. That is equals to 316.36. So now from here, what will be the P? P, okay, by 2 into area is equals to 316.36. Now area, let's see here, how much area will be there? Here. Right. That is from here. Okay. So just put that value, you will multiply. So P will be equals to 2 into area into 36. After multiplying this, you will get P equals to 335,929.5 Newton, or you can say approximately it's a 336 kilo Newton. Okay. So let's see once again quickly this question. So again, with the given condition, only we have to find whatever given condition is there, what is required, just like given data and what you have to find with the question mark. So here it's given as polished steel. This surface is polished. Okay. Where is from 0 to, so P mean, P max is given. Group of 2 mm deep is also given and having a radius of 3 mm. So from here we can find the area. Right. Okay. So this will be the area. The theoretical stress concentration factor and notch sensitivity is given, that 1.8 and 0.9. Outer diameter is given as 30 mm. The ultimate tensile stress is given 1250. Endurance given as 600 megapascal, and number of cycle given as 10 to the power 5. So now here number of cycle is given. So here we have to apply that logarithmic concept. Okay. So these things are given. So from here, this also is given, that SC dash, right? So let's see here. Right? The endurance in reverse bending. So just here, this word is important here, reverse bending. Right? Earlier also was there not endurance SE. SE is the endurance. Reverse is SE dash. Okay. So in reverse bending, all the factors what will affect that you have to multiply. Okay. So here, SE is given. Now, what we have to require, that KA, KB, KC, KD. K is what? Surface finish factor, because it's a polished, it's a 1. KB, size factor. For 30 mm, it's a 0. For finding that only the diameter, that is given that KB as 0.85. For 90% reliability, KC is 0.897. Now we have KC, KA, KB, KC. Now what is left? KD. For finding KT, what we have to find? KF. First find KF. So now for finding KF only, the KT value is given. Right. So from KF is what? The most sensitivity 1 plus Q into KT minus 1. After substituting the value, we got KF equals to 1.76. So KD equals to 1 by KF, reciprocal of that one. So KD is 0.568. Now, with this is the reverse, SE dash is the reverse impedance, and SE, that will be KA into KB into KC into KD into that SE dash 600. So after putting all the values and multiplying, we will get 259.84 Newton per mm square. Now that is given as reliability as 90%. So that's why 0.9 SUT is equals to, after multiplying this 1125. That 0. Just separately here found this one. Now take the log. So log of 0.9 SU is there. This SUT. Okay, equals to log of 1125. That gives 3.0. So this is 3.0512. Okay, now we have log of 0.9 SUT as 3.0152. Now just after, let's see, that is given. Log 10 S dash E here. Then this is what? Log, let's see here. Log 0.9, because up to 9 is there, so this is 0, or log 0.9 SU. This is the value, that is 3.015. So just after finding in that, right? So now we require to find this one, right? So that will be AD into EF by dV. AD is how much? That is given as 3.015. So from, because this is from here to here should be the total value, but this is from here to here, that is 2.417. So let's see a figure. So this total value should be there. So this is how much, right? This value. So this value will be this total, this from here to here minus this one, right? So this is total is 3.0152, and up to this is 2.14147. So after subtracting only we will get this one. So 3.0512 minus this value, we will get this AD value. Now what we require? EF. So let's see EF. So this starts from 3 and it goes up to 5. So this value will be 5 minus 3, right? So this is EF divided by dV. This is just for similar triangle AE. Okay, AE by EF equals to AD by dV. AE by EF equals to AE by dV. So from here what we can write? AE equals to AE into EF by dV. Sorry, dB. So that is only here. Just now dB will be what? Just here dB from here to here. So this is 3, 6. So 6 minus 3 is dB. So now from here we will get AE as 0.4243. Okay. Now just put the value in that one. Log SF. Log SF will be what? So see here again log SF up to this. This is the value of log SF. Right. So now AE. So from here to here minus AE. That we will get this value. Right. So just see again. From here to here, right, minus this value, if we will get, then we will get this value, right, from here to here. That only we will get. So this is log 0.9 SFU, right? SF. So log SF equals to that value 3.0152 minus AE, right? 3 point from here to here is 3.0512 minus this value. So we will get this one. So this value is how much? Just now we got 0.4243. 0.4243. After putting this value here, what we will get? 2.6296. After just putting the value of AE, how much we got? 0.4243. So 0.4243. After subtracting, we will get 2.6296. So after taking, because log SF is there, so taking anti-log and finding that value, so SF will be equals to 423.55 Newton per mm square. Now we have SF. But what we have to find? PA, the maximum value, right? That P max. So P max, let's assume P max as P and P mean as 0. So we have to find here the value of P. Okay. So now P mean will be equals to what? Half of P max plus P mean, right? So half of P max is P. So that will be P by 2 because P mean is 0. Similarly, PR, okay, PA is what? 1 by 2 P max minus P mean. So that is also 1 by 2 P. Now tan theta is sigma A by sigma m, and that is given as 45 degree, right? Theta is already we found, that is 45 degrees. So for tan 45 equals to sigma A by sigma m. Tan 45 is what? 1. So sigma A by sigma m as 1, and hence PA by PM equals to 1. So now what we can say, that PA equals to PM. Okay, for that 45 degree. Okay, now just SA equals to SM we got, just replace here, right? And another one is SA by SM equals to tan theta, just substituted that SA equals to SM, that is here. And after that solve for SA, or you can replace SM to SA or SA to SM, anyone you can do, find one then, but what we require, that SA required, so we are replacing SM. So after that SA, that is equals to SM equals to 316.36, this value we got, right? So now where SA is what? Alternating stress, and SM is mean stress, that already we know, but still I just mention here. So now maximum force will be what? That SA is PA by area. PA is what? That P by 2, and area. The P alternating, just we got that P by 2. P by 2 into area, right? The minimum cross section of the bar, okay, that is just given. So SA is PA by 2 area, that is SA already we got that 316.36. Just see here, SA that is 316.36. So after putting that value, what we will get, just P equals to that maximum is 336 kilonewton, or 33592.929.5 Newton. That approximately we can write that as 336 kilonewton. Okay, so now we found B. Okay, so again for your reference, you can just refer to the THG Maths and book, okay, the 4th edition. Okay, so if you have any doubt or any clarification, you can just comment on the video itself, or you can contact me regarding your doubt. I will clarify the doubts. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.